Hello everyone. So I hope you are hustling hard towards your dreams. We will be solving the second problem of the contest of the code forces round 112, right? This is a constructive algorithm, or you can say a type of greedy algorithm as well, right? Let's see the problem statement, understand it, and we will be solving it as well. So the problem states that when you are given two integers n and k, you need to construct a binary string s of length n where the both of the conditions holds. The absolute difference between the number of characters 0 and number of characters of 1 is at most 1, right? And there are exactly k adjacent pairs of equal character, right? That is s of I. If s of I is equal to s of I plus 1, then there should be exactly k pairs of that, right? So let us look at the two conditions which are given to us. The first condition was pretty simple. It was the absolute difference should be 1, right? Means absolute difference of count of 0 minus count of 1 should be at most 1, right? That means it can be 0 or it can be 1, at most 1. Great. So the first condition might be clear to you. The second condition states that there are exactly k adjacent pairs which are equal, right? Means if you are given a string, so s of I plus 1, s of I plus 2, so this character, this character, this character, so on and so forth till s of n, the number of characters which are equal, that is s of I, if it's equal to s of I plus 1, if that's the case, then this should be exactly equal to equal to k, right? It should not exceed k. Great. So these are the two conditions which you need to take care of, right? Now how will you take care of, right? See, when I say the number of count of ones minus count of 0 should be should be less than equal to 1, right? What do you understand by this, right? That, see, let's say in our whole solution we will be prioritizing one as more, so we will not add an abstract here. I will just say count of 1 is always greater than count of 0 in my case or in my solution, right? So what I will say is, say I will say, hey, how about how many ones should I place, right? How many ones should I place and how many zeros should I place, and they should be together, right? They are together. This is my problem statement for you, right? If I'm saying, hey, they are together, then how many ways are there to place it? It might sound, hey, what are you speaking about? First, let's try to understand how many maximum, what is the maximum k that you can have? What is the maximum k that you can have, right? Let's say if I had a n, let's take n as 10, right? So that we can understand. We will take 10 and take 9 so that odd even both are satisfied. So when I have 10, how many ones can I place? Can I place 5 ones and 5 zeros together, right? So they form a bundle and the consecutive can be maximized, right? Because we are trying to see how many maximum of them we can place, right? How many maximum we can place so that s of I is equal to s of I plus 1, right? So in this case, if you look at the case, right, 5 ones and 5 zeros will make up 10, right? You can't have 6 ones and 4 zeros, 6 ones and 4 zeros. This condition will definitely fail, yes or no? So the maximum that you can go is 5 and 5, right? And in this case, how many adjacent values will you have? This is adjacent, this is adjacent, this is adjacent, and this is adjacent. If you look closely, how many adjacent elements did you got? You got the total number of ones minus 1 adjacent values, yes or no, right? Similarly, in this, if you look at that, the adjacent values are 1, 2, 3, and 4. So again, total number of zeros minus 1, right? So this gives us a proof, right? Or we can, how can we make it generalized, right? So the way to generalize is, if we have a n, we know that n, for an even number at least, it can be n by 2 and n by 2, right? and from there the maximum that it will give is n by 2 minus 1, and this will also give n by 2 minus 1, right? Yes or no? Is it clear to you? Great. If it is clear to you, then let's see how does this solution work. It becomes 2 n minus 2 minus 1, and this is also let's say how many at max we can get. So n minus 2 plus n by 2 n minus 2, right? So it becomes 2n minus 4 by 2, right? So it becomes 2 common n minus 2 by 2. So you can see at max we can have n minus 2 terms which are there. Yes or no? Is this proof clear to you? This mathematical proof, how did we do? Why did we added plus? Because number of zeros plus number of ones, right? So the maximum that we can have is n minus 2. The first proof is here, right? Let's go to the, I hope the maxi for the odd even case is proven to you. Now let's look at the maxi case for the odd case, right? So how will we see the maximum number of ones that you can place is 5 in this case, and 4 zeros can be placed, right? This is the maximum consecutive that you can place. Yes or no? Now what I'm saying is, what will happen if you place 5 ones, right? How much will it contribute? The number it will contribute is n plus 1 divided by 2, which is 5 minus 1. Yes or no? Because let's see, this contributes 1, 2, 3 and 4, right? So 5 minus 1, which is 4, right? So this will contribute this much. How much will this contribute? This will contribute n minus 1 by 2 minus 1. Yes or no? Because n is 8, 9. So 9 minus 1 by 2, which is 4 minus 1. So it should at max contribute 3. See, 1, 2 and 3. So this is the final formula that we will have. Let me erase this part, right? So what we can say from here is the maximum will be n plus 1 by 2 minus 1, which can be converted into, let me erase this part. Yeah, so now mathematical is 2 will be the LCM, n plus 1 minus 2. Here also the 2 is LCM. Let's quickly add that up, n minus 1 and minus 2, right? So it ultimately becomes plus 1 minus 1 gets cancelled. So it becomes n minus 4, 2n minus 4 by 2 again. 2 can be taken common, n minus 2 by 2. So the maximum will be n by 2. Yes or no? So the proof might be clear to you why the maximum is n by 2. Now let's quickly think of, now we understood that hey, the first we can count how many ones are needed, how many ones will be needed, how many zeros will be needed consecutive, and then we can simply place them. Yes or no? We saw first the maximum, how much maximum can it be. If I will say hey, if my k is greater than maxi, then return minus 1, right? Because there is no possible way. But how many ones will we need? Let's say if my k was equal to 4, right? So if my k was equal to 4, half half should be distributed. So 1 should contribute 2 and 0 should contribute 2. If my k is equal to 5, 1 should contribute 3 and 2 should contribute 0 should contribute 2, right? Now how many ones do I need to contribute to? 3 consecutive ones are needed. Yes or no? See, 1, 2. So first we can find how many ones are needed. How many ones are needed means how much contribution of 1 is needed. That will be nothing but k plus 1 by 2. Yes or no? If k is, let's say, even, then it will be 5 by 2, which is 2 only. And if it's odd, like in this case, so 5 plus 1 will become 6. 6 by 2 is 3, right? So number of ones needed will be k plus 1 by 2 plus 1. We are adding, if 2 were there, so the number of 1 needed was plus 1. Similarly, how much 0 will be needed? It will be k by 2 plus 1. Yes or no? If let's say k is 4, then 4 by 2 plus 1, 3 is needed. If k is odd also, then also 2. So 2 plus 1, 3 will be needed. 3 zeros will be needed, right? So we can quickly place 1, 1, 1, 0, 0, right? And the rest of the part will be alternating because we don't want any consecutive now, right? All the rest part will be alternating. One last thing which left in the problem, which is the edge case of the problem. And what is the edge case? The edge case is the test case n equal to 6. Not just this test case, this test case will fail only if you implement this part, right? And k is equal to 3. Why it will fail, I will explain that as well. So when you do half of this, right, you will do k plus 1 by 2, that is 4 by 2, which is 2. Number of value, number of ones, it is this. And let's say number of zeros, how many zeros will I need? That is 3 by 2, which is 1, right? So how much 1 do I need? The number of ones I need is 3, and number of zeros I need is 2, right? So what you will do, you will simply say, hey, let's start placing it. Number of 1, 3, 0. And after this, as we have our consecutive have end, now we need to start alternating, and you will start alternating. Yeah. So I was discussing the main issue with this is if you place a 1 after this place now, see the count of 1 has become 4 now, right? And count of 1 is 4 and count of 0 is only 2. So at most difference has failed, right? So how are we gonna deal this? How will we deal this? See, whenever if my k is less than n minus 2, right, means it is not at the at max point, then what you can do is, for instance, in this case, n was 3, right? Sorry, k was 3, right? So what you can do is the first character you can place a 0, because every time you are placing, you are having 1 in more, right? 1 will be abundant every time. So what you will do, if your condition is if k is less than n minus 2, then you start with a 0 and then start placing, and then do the usual thing. Then do place how many ones are needed, then place how many zeros are needed, then place random 1 0 1 0, like this sequence, right? But you will start with a 0 every time, right? And why is so? What is the proof behind that? The proof is, see, the number of ones will always be greater than equal to 0, right? So in that case, there might be a few cases where the number of ones, as we saw, has exceeded the difference between 1 and 0 has exceeded 1, right? So that is the reason we will place a 0 at this place. But hey, why only if k is greater less than n minus 2? See, if k is greater than n minus 2, then the answer is minus 1, right? And if k is equal to n minus 2, that means that is the peak value that you can have. And for the peak value, you can see, if let's say n was 6 in this case, the peak value could be k equal to 4. So to get k equal to 4, you need to place three ones together and three zeros together, right? So in this way you can get two here, two from here, and two from here. So that is the only possible way, and you don't have any spaces or gaps left for you to place, right? So that is the reason for k less than n minus 2, we will start with a 0. The first character will be 0 and the rest logic will remains the same. If k equal to n minus 2, then we have seen that there is no spaces, the gaps are tight. And if k is greater than n minus 2, then the answer is not possible, right? So this was my greedy solution and the proof behind it as well. I hope you have understood the proof, right? Proof is always important, right? Remember these things in life. So maxi is n minus 2. We have seen why maxi is n minus 2. We can find number of zero ones. Number of ones will be equal to k minus 1, k plus 1 by 2 plus 1. Similarly, zeros will be k by 2. We create an answer variable, start from 0. If k is less than n minus 2, we'll start from I equal to 1 and answer plus equal to 0, right? Then we will place the number of ones, answer plus equal to ones. Number of zeros will be placed by number, while number of zeros is minus minus, we will place number of zeros, and after that we will place alternately. So we'll start with flag equal to 1. If flag is 1, then we will place a 1, convert flag to 0. Then if else the flag is 0, we will add a 0 and place a 1, right? And we do it until while I is less than n, right? So I hope the solution was clear to you. If you have any doubt in the solution, you can definitely do ask in the comments. I will try to help you out. Thanks for watching. This was it. And this time complexity of the solution is big O of n, right? We haven't used any double for loops, right? So the time complexity is big O of n. So that's it for this video. If you have any doubts, do ask in the comments. We'll see you in the next one. Thanks for watching.